Have you ever pondered the difference between a network and a circuit? These are terms you hear often, especially if you're interested in engineering, but their differences might not be as clear as you'd think. As we dive into their definitions, you'll soon realize the intriguing complexities hidden within these simple terms. It's a world where every circuit can be a network, but the reverse might not always hold true. Intrigued? Keep watching to unravel the mystery behind these fundamental concepts. A circuit, as simple as it sounds, is a closed pathway. It's like a roundabout in a city, where traffic, or in our case electricity, flows in an unbroken, continuous path. At the heart of this path, we have three key elements: a power source, a load, and a conductive path. The power source, much like a city's power plant, is where our electrical current originates. It's the driving force that propels the current around our circuit. Next, we have the load. This is where our electrical energy is put to work, powering devices like light bulbs or motors. Finally, we have the conductive path. This is the highway that our electrical current travels on, connecting the power source and load. Remember, it's crucial for this path to be closed, as electricity needs a continuous route to flow. So in essence, a circuit is a closed pathway, allowing the flow of electrical current. Moving on, what exactly is a network in the context of electrical engineering? Think of it as a bustling city where the buildings are electrical elements. These elements are interconnected, forming a network, much like a city's roads and bridges. A network, in essence, is an interconnection of several electrical elements such as resistors, capacitors, inductors, and so on. But here's a fascinating twist. This city, or network, can contain multiple circuits. Each of these circuits is a closed conducting path where current can flow. But in a network, there can be multiple paths for current flow, and might not contain closed path for current conduction. It's like having numerous routes to reach the same destination in a city. This makes a network more complex and versatile than a simple circuit. It can handle multiple circuits, manage different current paths, and accommodate a wide range of electrical elements. Therefore, a network is a more complex structure, an interconnection of multiple electrical elements. Now, you may wonder, can a circuit be a network or vice versa? Well, let's dive into this question a bit further. Imagine a circuit. It's a closed conducting path where electric current flows continuously. This could be something as simple as a battery connected to a light bulb. The circuit is the entire setup, the beautifully orchestrated dance of electrons from the battery along the wire to the bulb and back again. Now consider a network. It's an interconnection of components or subsystems. In the electrical world, networks consist of elements like resistors, inductors, capacitors, and voltage or current sources. They are arranged in a way that they influence the flow of electric current. So where's the intersection? A circuit, in essence, is a network. It's a specific type of network, one where the components are arranged to form a closed conducting path. But what about the other way around? Can a network be a circuit? The answer is, not always. A network becomes a circuit only when it forms a closed path for current to flow. If there's no closed path, no complete loop for the electrons to dance around, then we're dealing with a network, but not a circuit. In this way, you see, circuits and networks are interrelated, yet distinct. They are two sides of the same coin, two perspectives on the same fundamental concept of electrical engineering. So, while every circuit can be a network, the reverse is not always true. Let's take a moment to summarize what we've learned. We started off by defining a circuit as a closed path through which electric current can flow. We highlighted the basic elements of a circuit: power source, a load which consumes power, and conductors to connect these elements. Then we unfolded the concept of a network, which is a complex interconnection of components or nodes. We emphasized that a network can be as simple as a single circuit or as complex as the internet. We also touched upon the fascinating intersection of circuits and networks. We learned that all circuits can be considered networks, but not all networks can be simplified down to circuits. This is an important distinction, as it opens up a broader perspective on the complexity and versatility of electrical systems. Remember, understanding these basics paves the way to mastering more complex concepts in electrical engineering. Keep exploring, keep learning.